Welcome back. Now we're going to use this information we learned about being undefined and finding the restriction on the variable and solve some more rational equations. Remember, rational just means the equations contain fractions. The problem now is what happens if your equation has your variables in the denominator and not the numerator? Well, before you can actually go and solve that equation, you're going to have to state the restrictions. The numbers, the values, x cannot be. Because if your variable's in the denominator, you have to make sure your denominator does not become a 0. Because then the fraction would not even exist. So if everybody looks at the PowerPoint, I have an equation that contains fractions. 3 over x plus 2/3 equals 23 over 3x. Now here's the problem. It's all about definitions. Yes, that equation is rational because it contains fractions. It is not linear because x is not in the numerator. That x is in the denominator, and that is not the definition of a linear equation. The definition of a linear equation is ax plus b equals c. So even though it's x to the first power, because the x is in the denominator, that's not linear. Okay, it's just a rational equation. Now, before you go and solve for x, you have to come out and state the answers x cannot be. You have to state the restrictions. You got to come out and say what would make the denominator a 0. So we're going to go piece by piece. My first denominator is the letter x. What would make that denominator 0? Well, that's obvious, a 0. So your first restriction is x equals 0. My second fraction has a denominator of 3. There is no variable there. So there is no restriction on that fraction because the denominator is 3. And we can divide any number by 3. The third fraction, the denominator is 3x. So again, 3 times what number would make the denominator become 0? So if you write it as an equation, 3x, take the denominator, set it equal to 0. If 3x equals 0, if I divide both sides by 3, x would be 0. So on this equation, you have one restriction. The one restriction is x equals 0. That's coming out and telling us at the very beginning that cannot be the answer when we're done solving. Okay, that's what you're coming out and saying. X cannot be the number 0. Because if I did replace x with 0, I'd have no fractions. Because 3 over 0 does not exist, and 23 over 0 does not exist. Okay, so that's the first thing. So when you have a rational equation and your variables are in the denominator, they're going to make you state the restriction first. What the answer for x cannot be. What makes the denominator undefined. Once you do that, then your job is to solve. Well, again, to solve this rational equation, you can always use the LCD, and if it was a proportion, you could do cross products. Well, that's not a proportion. It's not one fraction equals one fraction. So we need our least common denominator. So let's look at our denominators. We have an x, a 3, and a 3x. X is prime, it's in lowest terms. 3 is prime, it's in lowest terms. And 3x is 2 prime pieces in lowest terms. So the rule of thumb is you take the most of every prime piece. So we need a 3 and we need an x. So our common denominator is 3x. So we're going to look at the PowerPoint and you're going to see I multiplied every fraction by 3x. Now, I don't want to multiply first, I want to do the division first. So in the first fraction, the x cancels out, and we're left with 3 times 3 is 9. In the second fraction, the 3's cancel out, and we're left with 2 times x, which is 2x. And in the third fraction, the whole 3x cancels out, and we're left with 23. So now you do have a linear equation. 9 plus 2x equals 23. We know how to solve that. We move the constant, we subtract 9, we divide by 2, and we get our solution x is 7. Is that number 7 the restriction? No, the restriction was x was 0. So that means that 7 is the solution. All right, we're going to practice more of this up on the whiteboard.